Any function. Make up a function, anything that you want.
Negative 5.2 squared x squared. I mean.
Negative 5.2 x squared.
Yeah. Plus 2.1 x.
What about natural log x cubed?
Yeah.
Okay, perfect. Now, can anyone help us find the derivative of this?
Negative 10.4 x
Plus
1/3.
You could bring 3 in front.
Oh yeah.
And then differentiate natural log, and it's 3 over x. That's the easiest thing to do. So this is the same with 3 natural log x. Natural log x prime is 1 over x times 3. Good. Can anyone give us the differential of y? Differential of this function. It's not the same. And I would like you to forever understand the difference between the two. They're not the same. The derivative is this. What about the differential? You already told me the formula is right here. I want this formula. That's what the differential of y is. How do I write this?
Negative 10.4x plus 3 over x
times dx. So remember, please, dy equals f prime of x dx. The differential of y is dy. And you can say, why is this so important? You'll see, especially in chapter 5. So the derivative of the function is just plain differentiation. The differential is still plain differentiation, but we have to multiply by dx. That's the only difference, but a huge difference. Okay, I'd like to start with an example and illustrate this with an example. Let's say that's my page 10. Okay. Approximate. Let's look at a problem. We can choose a problem directly from the book. And that's the last section. 3.11 is the last section, but if you remember, we talked about that. Okay, this is differentials. 3.10. And we can choose a problem from here. And then an application. Okay. I would like us to choose a problem from 31 through 36, in which we will use differentials to approximate. Choose any function you want.
Square root of 100.5.
The square root of 100.5. Very good. So the square root of 100.5. So they're asking us to approximate. So before I even look at this using differentials, I write my formula. F of x plus dx is approximately f of x plus f prime of x dx. This is the formula. Before I even uncover this, I know exactly what I need to find. I need to find f of x, I need to find x, and I have to find dx. Once I have the function, x, and the error, or change, minor change, x, minor change, and the function, The rest follows. I'll just plug them in. This means nothing anymore. I have to find the function. I have to find x. I have to find a tiny error. Once I have those, and of course I'll have to find f prime of x. Then once I have those, then I'll fill it in. Okay, so now let's look at this. Let's identify in here those three things. 1, 2, 3. What do you think?
F of x might be square root of x.
That's it. So then f prime is 1 over 2 the square root of x. So these two are done. Y, I need it here. Now I have to identify x and the tiny error based on the fact that this is a square root.
Is x 100%?
Exactly. 100, x and the tiny error,
Which is 0.5.
0.5. Because I can take the square root of 100. Awesome. So then, I copied the left-hand side, which is this. The square root of 100.5, approximately. F of x, when x is 100, how much is f of x?
10.
Yes. Plus f prime of 100. F prime of 100 is 1 over
20.
That's it. Awesome. Times dx, 0.5. So this is 10 plus. I multiply top and bottom by 10. So I have 5 over 200. I'll simplify by 5. So I have 4,001. I'm sorry, 401 over 40. So now I'm going to share my screen. And you can say, really? And I will say, really? So the square root, where's my square root? 100.5 and 401 over 40. Are you happy with the error? I'm very happy with the error. So the exact is 10.02496,883. So to speak, is not exact, but you know what I mean. And our approximation is 10.025.
Yeah.
It's very good, very close, because delta x or dx was 0.5. Okay. So this is the approximate symbol, but this is the equal symbol because I continue with this. So the square root of 100.5 using calculus, using what we just looked at, differentials, is 401 over 40. Yes, they're not equal, but it's a very good approximation of this. Any questions? Any questions? Okay, so let's look at a word problem on this, and then we'll go back to linear approximations. So before we even look at the word problem, so compute delta y dy for the given values of this. We sketched the diagram already, so just pick a problem, 23 through 26. So we are given the function, we're given delta x, which is the same with dx, and they're asking us to find dy and delta y, the exact and the differential. Please choose any function.
Can we do 23?
23, very good. So 23, y equals x squared minus 4x, x equals 3, and delta x equals 0.5, which is the same with dx. So they're asking us to find two different things. One is the delta y, which is difficult, not you know what I mean, not for this function, which is f dx or delta x. Let's use delta x when we use this delta x, minus f of x. So that what would that be? X plus delta x plus delta x will be f of 3.5 minus f of x, which is f of 3. So this is the exact. Yeah, so you know me, I'm going to plug it in. I'm going to plug in x squared minus 4x. And I want to plug in 3.5. And I want to plug in 3. Just give me the numbers. So the first one is negative 1.75 minus 3 is plus 3. So this is 1.25. This is the exact. What does this mean again? When the diameter of a disk is 3, but there is an error and it's now 3.5, there is an error that snowballs into y as well. What is the error in y? 1.25. So when the error in x is 0.5, the exact error in y will be 1.25. Now we want to approximate this with dy. So dy by definition is f prime of x dx. So f prime is 2x minus 4, and dx is dx. To determine the differential of y, all I have to do is say 2 times 3 is 6. 6 minus 4 is 2 times 0.5. And I get 1. Okay, so this is the approximation of that. Any questions? Any questions? Go ahead,
What
Evelyn.
did you just plug in there? So you had 2x minus
X is
4.
3. 2 times 3 is 6. 6 minus 4 is 2. And the x is, or delta x is 0.5. Is that okay? Other questions for me? Okay, so let's look now at a word problem. And then look at the linear approximation. That will be the last topic. Here we're asked to find the differential of this function. If we want to, we can. All we have to do is just add dx or d theta. You can, please choose one. So let's reinforce the differential, and then we'll look at a word problem. Anyone would like to choose any of this? I will choose 14. So in 14 we have y equals theta squared times sine 2 theta. We're asked to find dy. So that will be f prime of theta, which is this, times d theta, the variable in the function, the differential of the variable. So let's find y prime and then just put it in. Can anyone differentiate y for us? So f prime, so this is f of theta, f prime of theta. Can anyone differentiate, and which rule applies here?
Product rule.
Perfect. So we have 2 theta times sine 2 theta plus theta squared, careful now, cosine 2 theta times the inner function prime, which is the inner function prime is
2.
Very good. So then we have 2 theta sine 2 theta. Maybe this is better to put it like this, plus 2 theta squared cosine 2 theta. Now here, all I have to do is put everything in parentheses and multiply by d theta. So then dy equals all this times d theta. So 2 theta sine 2 theta plus 2 theta squared cosine 2 theta. This is it. That's all I need to do. You can say, what's this big deal? Well, you will see in chapter 5. It's a big deal. Okay, so now finally let's look at and illustrate this approximation with a word problem. Okay, the circumference of a sphere was measured to be 84 centimeters with a possible error of 0.5. So in 43. Again, the circumference of a sphere was measured to be 84 centimeters with a possible error of 0.5. What is this?
EX.
Yes. Now, it's better if you said the x. It is indeed the x or delta x. But then I have to change this into x, which is fine.
EC.
It's fine. No, it doesn't matter. It's not important. As long as we know that x is the circumference, that's fine. That's easier. Good. Awesome. Let's go back. So they're telling us that x is 84 centimeters, but x may have a possible error of 0.5. Use differentials to estimate the maximum error in the calculated surface area. We'll come back to the rest. Use differentials to estimate the maximum error in the calculated surface area. Okay. So here's a sphere. And the circumference, it's the circumference of a circle. So we normally write c equals 2 pi r. We are going to write x now because we decided that our circumference is denoted by x. Nothing wrong with it. 2 pi r, and this is r. Okay? So they're telling us that the circumference has an error of 0.5. Now they're asking us to find the estimated error in the area. Use differential to estimate the maximum error in the calculated surface area. I'm sorry, surface area. So remember the surface area. So it comes from 4 pi over 3 r cubed. So it's 4 pi r squared. So this is the surface area of the sphere. I didn't mean to shade in just that. I don't want to confuse you. We are looking at the surface area of the entire sphere. Okay. So they're asking us to use differentials. They're not asking us to find delta S. They do not want the exact. No. If they don't want the exact, they want the approximate. If they want the approximate, it means that they want ds, the differential of s. Can anyone give us the differential of this function? Exactly how we did it here. It was theta, but now it's r. How do I write? Yes.
4 pi
Yes.
times 2r,
Yes.
or
Yes.
2r times
R. So this will be the derivative, but I have to multiply by
the x.
the variable. We cannot use x for the circumference and x for the radius. We used x for the circumference, then I have to use r for the radius. So this function has r in it, so that's why we multiply by dr. So this is the differential of the surface area. Okay, perfect. They want us to calculate this. Okay, now we do have the circumference as being 84. So 84 equals 2 pi r, because I need to determine r. First, I have to find r. And we are told the circumference, which is 2 pi r, is 84. Can I find r from here? Yes. I divide both sides by 2, I get 42 over pi. So this is done. 42 over pi. Now I need to determine this, which is dr. Now you can say one option will be to find dr from here. So I have dx, which is the circumference, equals 2 pi dr. So then I have dr equals dx over 2 pi. So this is dx over 2 pi. Now I have everything. I have all the numbers I need. So then ds equals 8 pi multiplied by 42 over pi multiplied by dx, which I have, 0.5 over 2 pi. So this pi with this pi, this 2 with 21, and I'll punch in everything else in the graphing calculator. And then I have 8 times 21, multiply by 0.5, 8, 21, 0.5, and divide everything by pi. So I got approximately 26.838. And of course, this is a surface area, so this must be in centimeters squared. Any questions so far? Any questions so far? Okay, final question here. Where are you guys? So we can do this also is the same thing with the volume, which will be 4 pi r cubed, the same idea, same steps. But I want to finish up with this one. What is the relative error? Okay, so let's talk about the relative error. And I'm on page 13.